I'm Connor Gorman. I work at StackRox. I'm a staff engineer there. And we're a container and Kubernetes security company. So it's no surprise to anyone that I'm going to talk about Kubernetes security. So first, I'll just give you a quick overview. What we're going to work on, or talk about today, sorry, is just general Kubernetes hygiene for security, right? It's kind of like a high level. And then we're going to do a deeper dive into workload best practices. And I'll interleave a demo with some of the best practices and why they actually matter, like in a real world scenario of attacks. And then I can take any questions you guys might have. Cool. So what are we all doing here, right? When I think about Kubernetes, right, some of us are pushing Kubernetes at our organizations, and some of us are getting Kubernetes pushed on us at our organizations, right? And really what it marks is kind of like a huge paradigm shift in infrastructure and the way that we manage software and applications, and the way that developers actually end up deploying their applications, right? When you think about DevOps, right, it's every SRE's dream to have developers manage their own applications, but that means that they're pushing code to production, right? And we're building pipelines for people to quickly develop and push code, and from a security standpoint, it makes me a little scared, right? I'm a developer, I still am. I worked in infrastructure before I worked at StackRox, and I don't think I thought about security like one time. And basically what I would do is get, develop code, make sure it works on Docker containers, push it, and hope for the best. And now taking a security view, it's probably not the best way to go, right? And so how do we build security into rolling out our software? So first and foremost on Kubernetes hygiene, please update, right? Make sure you stay up to date. If anyone remembers, Kubernetes 1.13 deprecates etcd 3.0, right? If you're still on 1.12 and a vulnerability comes out, maintainers don't patch, they patch for the last 3 releases, right? And the last thing and the last space you want to be in is having to update your data backplane while trying to fix a vulnerability, right? These things are usually best thought through, planned out, a firm idea of a migration, and you don't want to be stuck in this scenario where you're trying to fix a critical vulnerability, but also rolling out tons of new infrastructure, right? I think everyone can agree infrastructure upgrades are as scary as they come, and don't do it quickly, right? So in order to upgrade, and even know that you need to upgrade, right, you really want to follow the community and see what's going on, right? And so I love this Google group. They post a ton, and you'll get a bunch of information. Actually at StackRox as well, we have like a Slack channel, and then you can post all the news from Kubernetes in there, right? Just make sure you're up to date and you understand when new CVEs are coming out, whether or not they affect your organization, and what you can do to remediate them. These are like amazing resources for looking at that and understanding, kind of where your risk lies in the cluster itself. So more concretely, like let's make sure we still use best infrastructure practices, right? Like these ideas and concepts that we've had for a long time don't go out the window. Let's make sure that our network access is firewalled off correctly. Let's make sure our Kubernetes API server, which is basically the entry point into all of your infrastructure, is locked down. And I know a lot of people will restrict it to a VPC or their company's VPN, just to ensure that the traffic to the API server is protected. And then lastly, from like a purely host perspective, right, let's make sure that the actual host itself is locked down. Google's done a bunch of stuff with this with costs, right? Container optimized OS, right? And something that's really interesting that's come out super recently is ephemeral debugging containers that Kubernetes started to think about and work on. And this gets me really excited because I know when you're trying to debug networking in the Kubernetes cluster, it can be such a pain. And the idea of these ephemeral clusters is to run debugging images alongside your pods, binding to the same namespaces, and then you can debug right there without having all the root privileges or having a container that's constantly full of network tools available, right? I think the world where you run one application inside a container with one process is sort of the dream, but that's been tough when you need to debug and actually like try to test stuff and see if it still works. So alongside the API server, obviously please use RBAC, right? Your API server is locked down to your VPN, but then let's make sure the people who you expect to use your API server are accessing the correct resources. I think a really solid way that people have been doing this is through continuous deployment systems, right? So you push a lot of the RBAC into the continuous deployment system, which is usually hooked into some version control, right? And then you use kind of your normal authentication through GitHub. You have an automatic audit log of what's changing in your infrastructure, right? And then the only access point in terms of modifying workloads is in the continuous deployment system, right? So you really have one service account authorized against your API server. And obviously you still have people who need access to the cluster, right? You still need to debug and fix, but now since you have so many fewer users and groups, it can be really effective to do that. So now you have a much smaller number of people you need to manage in RBAC. And Kate's RBAC can get a little unwieldy. You have to figure out what all of the verbs mean, what all the resources possibly exist, right, and all of the subjects. And Kate's, by design, has a very open policy of RBAC. So initially, everyone's pretty much an admin. And you want to quickly try to scope that down. So in general, I think we should definitely use Kate's RBAC, but I think you should try to work in your organization to make a way that it's kind of streamlined for everyone, because it can be pretty difficult to manage. So that's kind of what I have on overall Kubernetes security in terms of like the actual cluster and infrastructure itself. And now what I consider a little bit more interesting is securing the workloads. And I actually think that containers in Kubernetes provide kind of a new way of securing workloads, because now you can look at a single application and scope down the surface area to exactly what that application uses and needs. So first and foremost on workloads, please leverage namespaces. I don't know if you've ever seen a default namespace full of 150 deployments, and no one knows whose is whose, and no one can figure out exactly what each does, and there's zero segmentation between any of them. It can be a real headache for everyone. So namespaces are great for resource usage tracking, for seeing, hey, which team, which tenant is using a lot of resources. It allows RBAC to be finely tuned, so you can have a certain namespace, you can give someone just access to those resources. It allows for generic network policies and segmentation. I know a pretty common use case in the Kubernetes cluster is you have two tenants, you're running a SaaS model, and you don't want any of the tenants to have any connection to each other, right? Network policies give you a really nice way to just completely block between those. And then finally, I think my favorite is makes kubectl results a little bit more sane. So you're not grepping and awking through all of the results or trying to filter via the right labels. And it also makes the API responses significantly faster, so namespaces are great. So in general, the way I think about risk in terms of workloads is kind of in this amazing hexagon type pattern. It starts with building your image, looking at the dependencies, the packages, analyzing the vulnerabilities, right? Because that's definitely a spot that you need to analyze. So vulnerability scanning is pretty key in looking at the known bad in an image. Then you look at kind of how the app is configured, right? In terms of what privileges it has on Linux, what privileges it has against the API server in form of service accounts, right? And what other sensitive data it may access, API keys for registries, sensitive databases. And then actually on the far right, the part about labels and annotations I think is really key, which is basically how do you loop back when you look at a service to say who owns this service, right? An annotation of owner or email or team is super valuable in basically doing kind of the debug cycle for operations and looking and making sure that you can route that quickly, as opposed to kind of the murder mystery of trying to figure out, hey, who owns this application, who deployed this, right? And you can immediately route back to the right people. So some key configurations that I personally love in containers are the read-only root file system, Linux capabilities, and network policies, and I'll elaborate and demo those. And then there's way more than the 7 that I put on this slide, but there's a ton of configurations that can affect your security posture. So for the read-only file system, it's pretty much exactly what it sounds like, right? You can make your container file system read-only. That means that no one can write to it. I think a really common misconception here, though, is that it's either I make any write and now I can't be read-only, when in reality what you can do is create empty directories and volumes, or you can use the volume command in a Docker file, and then that can make that specific path read-write, where the rest of the file system is read-only. And the real reason this matters is, I don't know if you guys have ever used Metasploit, which is a penetration testing tool. A majority of Metasploit exploits end up dropping payloads to /temp, right? And the reason for that is that traditionally, /temp is always writable. Tons of applications rely on the fact that temp is writable, and so attackers try to use the same assumptions that normal applications use to ensure that they can write like binaries and execute them. So even doing something like this, where you make a specific path read-write, and the rest of it read-only, can easily like thwart an attacker who's just running a script against your service. So the demo I have, and I'll just pray it works, and we'll see what happens, is I have a vulnerable Struts deployment. Right? This is the classic vulnerability that Equifax got hit with, and well, they definitely stole mine, and hopefully none of your social security numbers. But I'm just running a Struts server here, and then I'll run an exploit. And this exploit is remote code execution. What we ended up doing is that on the backside, it opens a shell. We download a crypto miner, write it to the file system, make it executable, and execute it. Right? And so now what effectively happened is I have a crypto miner running in my environment, which obviously sucks because they're stealing my resources. Right? Luckily, they just did a crypto miner. So in the case where we have a read-only root file system, I'll do a quick demo to see how this changes like the impact of this particular attack. So we'll hopefully wait for this to create. Great. And I'll run the same attack. Right, so in this case, the wget call to the miner D binary ended up failing because the file system is read-only. The next point that this kind of brings up is like when, this is all backup slides, when can I figure out if my app can be read-only and what file paths need to be read-write, right? It's not always super easy. You know, for example, this is an Nginx container. You know, I didn't write Nginx. I don't know exactly what file paths it writes, right? But even just running like a basic Docker diff on the container that's been running for a while, you can kind of see exactly where it's been writing specific paths, right? So obviously this one is something we need to worry about, right? This will probably stop. Okay, cool. Obviously, we need to worry about the Nginx PID because that's definitely written by Nginx itself, right? And that'll probably stop it from running, right? The running of the secrets, Kubernetes will always write those paths, so I don't worry about those too much, right? And then in this case, what we can see is that var cache Nginx, right, is kind of like a root file system. And so what I'd like to do is I'll probably put an empty directory at var cache Nginx, right? Because we know we need to write these other 5 temp files, right? So in this case, I can make Nginx completely read-only, except for 2 specific paths.
Is it possible to make that path no exec?
So no. So Kubernetes doesn't support no exec, which has been kind of a point of contention. Cool. So yeah, that worked. Awesome. So the next kind of area that you can really slim down your container is in Linux capabilities, which a lot of people haven't used, and they're definitely way more behind the scenes in terms of containers and applications, because they don't really have, you don't really call them directly, right? Like what you are doing in your application ends up calling Linux capabilities. And the whole idea is basically to take the root superpowers that root can do everything, and let's split it up into defined tasks. And for example, these here, right, are kind of really, really common ones used. But Kubernetes gives you the ability to drop capabilities and add capabilities that you need to use. And so what I did in order to see what Linux capabilities the Struts application was using, in this case, this is with the minerd exploit. It downloads a tar.gz and untars it. So I used the eBPF probe that's actually written by Brendan Gregg from Netflix. And what it does is it listens to a specific spot in the kernel and looks for the capabilities that you're trying to use, right? And then can pull those out for you. What that can do basically is give you like a list of capabilities that you need to use. You know, they're not super easy to get to, but they're just equally as powerful in stopping an attack. So in this case, this is all you need to do is I just need to drop all the capabilities because Struts is listening on an unprivileged port and just responding to requests. Doesn't actually use any specific root capabilities. And then we should hope this happens, which I will show you, and I will hope it happens. Come on, Kubernetes. Cool. Right, so in this case, we were able to reach out to GitHub, download the minerd, But when they wanted to change the ownership and then eventually create chmod or -x or +x, the binary, it ended up failing, right? And so sometimes you can't always make your file system read-only, but this is another thing that you can do to limit the surface area of your container if you know exactly what your container needs to do. So the next topic, the last kind of piece, the last layer to look at, right, is how do I prevent the network call in the first place, right? Like, I know that Struts isn't supposed to be reaching out to the internet. It doesn't. It's it's only taking incoming requests. How do I just block it completely? And the answer is network policies. So the way I think about network policies is that there are L3, L4 firewalls, right, with some extra context added for Kubernetes. So when you look at what this particular network policy would do, the first pod selector is selecting anything with the label, right? So it's very generic, and it selects a web application. And then the ingress is saying what can talk to it, right? So in this case, you could imagine you have Prometheus running that is scraping endpoints in different namespaces. And what this will do is allow anything from the operations namespace of type monitoring. So that could be a Prometheus server that we have running, and it'll be able to scrape application web. And I'm just defining exactly that path between that namespace and my web application, and just restricting the traffic. Security is hard. So the network policy that I'll apply to my Struts container is basically denying all egress, right? So my container has the label app and the value API server, and the policy type is egress. Now, kind of a pain with network policies is that since I didn't supply any of the rest of the YAML, that means I block everything, which is not always completely obvious. So definitely you got to look at the documentation sometimes, test these things before you move them to production, because they might not always have the impact that you think you're having, which can kind of be one of the issues with labels. So in this case, I'll go ahead and add a network policy, and I'll rerun the exploit. It's taking longer than before, because the network call from wget is hanging, right? So we never even got to the point where we're trying to run the -d. We have created a network policy to block that connection, and wget is basically just hanging on a connect timeout and will eventually time out. So this is a way that you can just totally prevent this entire attack based on the knowledge that you know about your application, right? And so a lot of the times, the developer itself will know a lot of the interactions that their application needs to make, right? And can look even at things like mesh and see where the service-to-service communication is, and you can craft network policies based on the active connections that you've actually seen. And really slim down the surface area and attack surface based on the network, right? And then you're looking at the file system, and then even the capabilities and privileges it has within Linux. And this can give you like a really, really good security posture from a workload perspective, especially if you can kind of build this into your developer's workflow. So the last thing to always remember is that security is hard, right? Security is like a marathon battle, right? Like, there's no such thing as like really perfect security, but it's always about monitoring, iterating, right, and making sure that the tools are available for people who are building the code to kind of integrate it into their process and really drive security. And that's all I got for you guys.
Sweet. I appreciate that sly wink defining you need to mirror traffic, like with traffic to define your network policy.
Yeah, when he was up here, I was like, ooh, okay.
Yeah, that was good. Any questions on Kubernetes security?
Have you worked with seccomp at all?
Yeah, so you can definitely pull the syscalls, right, from like a particular container and look at seccomp. I find seccomp to be like a little tough because it's like very absolute, right? So if you turn on seccomp profile for a container and you're wrong, like it's totally not going to work. I'm almost a fan of like pseudo seccomp, where you basically say like, here's the seccomp profile I think it should have, and then you can validate events against that, and then highlight them if they fall out of your seccomp profile to be investigated. But yeah, seccomp can be it's really powerful, but it can be really tough to use.
Well, You mentioned earlier the ephemeral container technology is coming out. Is that coming in 1.16 or is that currently out?
So I'm not sure if it's in 1.16. I think it might be in alpha. But I was just reading some stuff on it today, and I was pretty excited that they're kind of moving that direction because I know that's been a huge trouble for a lot of people. And you don't necessarily want to restart a pod to add a container that can do debugging because then you've lost the whole context of whatever you were trying to debug.
Cool. Well, I saw some news about the ephemeral stuff along with 1.16 stuff. It sounds like they're getting really close to cutting a release. So that should be heading everybody's way soon. Cool. Round of applause for Connor.
Thank you guys.